Okay, good morning. We combined resistors in the previous lecture, series and parallel. Now let's see what happens to sources if they are in series or parallel. Let's start with voltage sources. So you have 4 voltage sources in this circuit, right? And 1 resistor. In order to understand how we can actually combine sources, let's write some equation for this circuit. As always, I'm going to ask, which equation is more suitable for this circuit? KVL, because we only have 1 mesh. So let me write KVL here. Before writing KVL, what should I do? I'm going to call it I and call this Vx. Okay. Start from that side this time. What's your name, sir? What's your name? Andrew. Could you please start the KVL for me? Negative V1, thank you. Next. Anuj, right? Plus I R1. Do you agree with him? It should be plus or minus? I want it loud. Plus or minus? So we don't care about that label, right? Is that obvious? We don't care about the Vx label. Okay. Next, Dikshant, right? Plus, what did you say? V2, yeah. Sorry. Next, plus V3 and plus V4 equal to 0, right? So let's move things around and see what we can write here. So I'm going to write it like that. Negative V1 minus V2 minus V3 minus V4 plus IR1 is equal to 0. Do you agree with that? I just factor out the negative of all the voltage sources, and yeah, I get to this point. And whatever is inside the parentheses, I'm going to call it VEQ. So from here, I can write negative VEQ plus IR1 is equal to 0. Now I'm asking you to do this for me. For this equation, we're going to do something backward. For this equation, can you draw a circuit? How? I want you to draw a circuit whose KVL is that, the last equation. Where should I start with? With a voltage source, right? What's the value of the voltage source? VEQ. Then? Let's talk about that later. What's the next element? A resistor. Okay. So how should I choose the polarity, the terminals of the voltage source?
Current should be flowing in the negative terminal.
Why?
Because it's negative in the KVL equation.
Because it's in the KVL, it's negative VEQ, right? Okay, any problem so far? So how can we combine voltage source in series? This is how I suggest you do it. First of all, because the voltage source are in series, they're going to be either added or subtracted. Is that obvious enough? Because they are either enforcing each other or they are actually in competition. Okay? Now, one way of doing it is like that. Take one of the voltage sources as your, I don't want to say reference. Take one of them as your, as the one that you want to set the polarity based on. For example, I've chosen V1 as my base voltage source. Okay, I'm trying to avoid using the reference so not to confuse. So V1 is my base. Now, there are a couple of ways that you can handle this. I mean, this is not difficult. Okay, so me saying it doesn't mean that you have to spend time on it, but I just wanted to give you an example. Have you seen those appliances or toys or, I don't know, remote controls, especially the old ones, where they needed, for example, 2 AAA batteries, okay? And if you consider this is the knob and this is the flat side of a battery, this marker, and this is the red marker is another battery. Now, do you remember how we usually put them together to give 3 volts of voltage to that appliance, considering each one of these are 1.5 volts? Did we do it like this or like this? I mean, head to end, right? Front to end. So this is what we chose them to. Why didn't we do it like that? The other way. They would provide 0 because one of them is trying to give positive 1.5 and the other one is canceling. But when you put them back to, how do you say it, head to back, okay, then it will create 3 volts for you, right? So can you tell me which voltage sources in this setup are enforcing V1? None. All of them are actually in competition with V1. Do you see how? Okay? If you consider the positive side of the voltage source as the cap of the marker and the negative side at the end of the marker, okay? So see, V2 is like that, V1 is like that. You connect them together, they are in competition. They are not enforcing each other, okay? One other way of thinking like that is that voltage sources try to supply power to the circuit, right? And this is how they usually do it. They push current out of their positive terminal, okay? This is something that you can remember for handling these cases. So they push current out of the positive terminal. The current that V1 pushes out to the circuit, is it agreeing with the current that the other sources are pushing into the circuit or actually opposite direction? This is opposite direction. See, V2 pushes it to the left, V1 pushes it to the right, okay? So that's why we end up with V1 minus V2 minus V3 minus V4. Did that make sense to everyone? So remember that pay attention to the polarity of voltage sources when combining them. So if they are in series, we can easily combine voltage sources. Let's see what happens if they are in parallel. So let me see if I assumed any value for those. No. It's not a bad idea to write some values for these. For example, let's say this is 5 volts, 2 volts, and 3 volts. Okay? How can I simplify this circuit? Anything bothering you? What? Why? Do you see what's wrong here? How can you have voltage sources with different values in parallel? What does a voltage source do? The voltage source tries to force the two nodes that it's connected to be equal to some value of voltage. For example, the leftmost one tried to force the voltage between the top and bottom terminal to be 5, the middle one 2, the rightmost one 3. So, I mean, which one is going to be the winner? Okay? So this is not a circuit that we are going to handle in this course. This is not possible. Let me put it this way. Okay? You may ask, but it doesn't make any sense because I can have 3 voltage sources with 3 different values and connect them in parallel. What's going to happen? The circuit starts talking and say, I'm not possible. Something is going to happen in the circuit, right? This is not going to be covered in this course. We're going to talk about a little bit. Maybe in future lectures, if I remember, I can talk about it. But right now, no. So just ignore this case for now. We can't have this. So the conclusion is this. The only way voltage sources can exist in parallel is when they have the same voltage and same polarity. So not possible at least for now. Okay? Any question? Let's see how we can combine current sources. How should I analyze this circuit?
KCL.
KCL. So, is there something I need to do before starting to write KCL? Label the top node something, V for example, and then write KCL. KCL at V. Okay. Who was next after Isaiah? What's your name, sir? Richard. Do you remember the red box? Do you want to pass? Okay, that's fine. Next one.
Can we do what we did in the very first one? Do that one. Talk to the audience. Like mesh.
Which one? Do you remember the red box? No? Next. What was your name? Kevin, right? Kevin.
For the first grant, what did you feel about?
Can you tell me the complete one so everyone knows where it is coming from? V minus 0 over R1. Yeah? Do you remember the red box? If you don't, refer to that. If you haven't seen it before, then there's something wrong. Okay? So go to the previous lecture. This is super important, the red box. So V minus 0 over R1. Next, Ernest.
Would be negative I1.
Why negative?
Because the current is
because the current is entering the node that you're writing KCL at. Next one, please. Plus I2 and minus I3 equal to 0, right? Let's move things around. Can you suggest a circuit for the let me actually call this IEQ. Minus IEQ is equal to 0. Can you suggest a circuit for the last KCL equation? So first a resistor, then a current source, okay, let me do this. What is the direction of IEQ? Down or up? Who says down? Is there anyone saying down? No? Why up? First of all, it's entering the node, so in the KVL, in the KCL, it appears with a negative sign. What's the other way of finding that it's going up? If you look at what IEQ is, see, IEQ has the same sign as I1. Do you see that? IEQ is equal to I1 and then some other term. So its direction must be consistent with I1. Do you see that? But if you look at I2 and IEQ is negative I2 and some other terms. It means that I2 and IEQ should have opposite direction. That's one way to look at it. Okay? Does that make sense? Okay? How about series? How can I combine current sources in series? It's the same. It should be the same, right? Otherwise, there's something wrong that we cannot handle right now. Because if one of them is trying to push the current to be 2 amps, the other one 3 amps, then we don't know which one is going to win, right? So for this case, what can we write? We can write that I1 is equal to I3 and is equal to negative I2. Okay? That's it. No other cases can be handled right now. But something that we didn't talk about here, so first of all, this is not possible. The only possible case that we could have is this, when V1 is equal to V2 is equal to V3, right? That's the only possible case for that. Now, my question is that since they are all equal, what can we do about the circuit? Is there any way to combine or simplify the circuit? Pardon me? Okay, what should I do to the other two? Remove them. They're not doing anything. One of them is enough to set the voltage between these two nodes equal to whatever value is that. The next two are just repeating something redundant, right? So you don't need them. Just remove them. Open circuit. Just remove them, throw them away. How about here, this case? Should I open them too? What should I do to them? Short circuit, okay? So for current sources here, you should make them short circuit because if you open it, then the whole current in the circuit will be zero. Current cannot pass through a circuit that is open, right? So just ignore two of them, like replace them with wire or short circuit. So let's do an example and see what's going on. We want to find the V5 ohm and I5 ohm and see what we can do here. Okay. So what do you suggest combining? Let me ask the next person. What was your name? Chris? Okay. What do you suggest combining here? The two 1 amps? Okay, yeah. What should I do with them? So one current source is enough, right? What was the direction? At the same time, let's do the right-hand side as well, right? Do you see the right-hand side? What's the value? 7? 3.5 and 3.5, right? 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 Just one of them, okay? They're not supposed to be added together. 3.5. Next. What do you suggest we do?
Get rid of the two 3.5 and just get the 7.
Okay, why did you add them?
Because they're in parallel.
They're in parallel. And they are in the same direction, okay? So they are pushing the current to that node at the top, both of them, each one 3.5, so you can replace both of them with a 7. How about to the left side? You have one 3 amps going up and one 1 amp going up. So I can get rid of the 3 amps and replace the 1 amps with 4 amps, right? Next step. Yeah. You can get rid of one of the 4 amps, right? Because it's redundant.
Can you do the same with 7?
Absolutely, yeah. And finally, yeah.
Subtract the 2 from 4. Oh, no, subtract. So add.
Add 2 and 4.
Is that how much you do?
Subtract, yeah. Why?
That's what I said at first, and I switched it, because I saw they're still going clockwise.
Okay, if you do that, you will get the direction wrong. This is what I recommend when you are dealing with combining sources. Focus on the top node, okay? Are both of them pushing current to that node? No, one of them is pushing, one of them is pulling. That's why they are opposite directions, okay? Don't look at the mesh, okay? And are we going to combine only those two? And the 7, right? They are all in parallel, so you can combine all of them. So this is 5 ohm. What's the value of the equivalent current source? It's 4 plus 7 minus 2, right? 9 amps. So this is V5 ohms, and this is I5 ohms. What is I5 ohms? 9 amps. And what is V5 ohms?
9 times 5.
Any problem? Okay. A very useful concept in handling circuits is voltage division. There's a problem with this concept, and most of the students try to avoid using it, okay? Because you can. You definitely can avoid using voltage division and do it some other way. But the advantage of using it most of the time is significant, okay? So it's really worth it that you learn this method. So let's see what I mean by voltage division. Let's write a KVL around this guy, and instead of dealing with current, I'm going to deal with voltages. So how do I write the KVL? Yeah, direction. Yeah. Always clockwise.
Okay.
Yeah. But I'm not using current. Okay. Negative?
VS.
Negative Vs. Next? Yeah. Positive V1, yeah. Next? Positive V2. Equal to 0, right? Okay? Then I will write Vs is equal to V1 plus V2. You all agree with that? Now, based on Ohm's law, if this is my current, I, can you tell me what is V1 equal to? I need it fast. I R1, right? What is V2? I R2. And it's equal to R1 plus R2 times I. Okay? So from here, you can say that I is equal to Vs divided by R1 plus R2. Was there any other way much easier to say that the current in this circuit is just Vs divided by R1 plus R2? Before doing the Ohm's law, instead of writing 3 lines of KVL equation, yeah, you're right, Ohm's law, but what is the resistor? Combine the resistor and do only Ohm's law. That would have been much easier, right? I mean, the reason I did it because I want you to practice KVL, but if you just combine the resistors, you get the last equation very fast. Okay, so far we haven't done anything special or new. Now, let's find V1. Remember, this is V1. And the same goes for V2. So V1 is equal to I R1. And instead of I, I'm going to write the equation that I have, the expression that I have for I, which is Vs divided by R1 plus R2 times R1. I'm going to rearrange it and write it like that. V1 is equal to Vs times R1 divided by R1 plus R2. With the same logic, I can write V2 equal to Vs R2 divided by R1 plus R2. One question. What's the point of these two equations? But we could have found it. If you look at V1 and V2, they are equal to IR1 and IR2. So what's so special about these two equations inside the red boxes? You don't need current for them. That's why they're called voltage division. And they are super useful, okay? You don't need to calculate current. You can bypass calculating current and just go directly and find these voltages. Now I want you to take a second and look at the equation, see if they are making sense. Logically. So for example, I have a 10-volt voltage source. I don't want you to write anything, and I'm not going to write anything, okay? I have a 10-volt voltage source, and my resistors are, let's say, 40 ohm and 60 ohms. 40 ohm and 60 ohms. How much voltage is dropped across the 40 ohms? Do you want me to repeat my question? I have 10 volt of voltage source, and my two series resistors are 40 ohms and 60 ohms. How much voltage is dropped across the 40 ohm resistor? 4 volts. How much is dropped across the 60 ohm resistor? 6. So the voltage that is dropped across the resistor is going to be larger if the resistor is larger. Is it making sense? Do you see that V1 is directly proportional to R1? V2 is directly proportional to R2. Okay? These are all just hints to help you memorize this. Okay? These are super useful equations. Any problem with understanding them? What's the logic behind them? No? Good. So, if Vs is equal to 10 volts, here, R1 is 40 ohms, and R2 is 60 ohms, without writing anything, can you tell me what are the values of V1 and V2? Sorry? But the value of the resistors are different. Do you see that? Very common mistake. Resistors are in parallel, you go for voltage division. Should you? No, because both have the same voltage equal to 10. Okay? So when can we use voltage division? In series. Everything in series. You have a voltage source in series with two resistors, okay? And then you can do voltage division. Any problem? One thing that I want you to remember is that how we define and set the polarities of Vs, V1, and V2. Okay? Pay attention. So remember that V1 is and V2 are defined like that. And let's do this example and see if you can handle the polarities well. So before this lecture, if I ask you to find V6, how would you do it? Combine the resistors and do what then? Find the current, right? And then multiply the current by 6, right? Now, I want you to do it using voltage division. What is V6? 5, the main voltage source, multiplied by a fraction. What is that fraction? 6 ohms for numerator. What is the denominator? 3 plus 6 plus 10. I don't know what's the value. I just written it as 30 divided by 19 volts. What is V10? 5 times, what's the numerator? 10 ohms. And the denominator is, again, 3 ohms plus 6 ohms plus 10 ohms. Equal to 50 over 19 volts. Is everything correct? Yeah. Should it? Why? Look at the polarity of V10. It's the opposite of what we have here, if you remember how we define them, right? Does that mean attention? What is attention sign? Is it? What does this mean? Danger? Danger. Yeah, danger is good enough. If you don't want to see my face next quarter, so this is dangerous enough, right? Okay, so let's go for current division and see what we can say about that. Let's call that V. So, without writing KCL, I want someone to tell me what is V. the most straightforward way, probably, based on your knowledge of KCL and KVL, is to write KCL at V. But you should know a much simpler way of doing this. What is that? You, yeah. Plus. No. Again. I'm going to write it first, what she said, and then you tell me if it makes sense. Anyone doubting this? What is that fraction? It's the parallel of R1 and R2, right? And do you agree that IS is the total current that passes through the combination of those resistors? So what is that law technically? Ohm's law. That is Ohm's law, right? So that is much easier than doing KCL for this specific circuit. Okay, so that is your V. Now,
would it be negative? So IS is flowing into the voltage.
that was for something else. Do it like this. If I want to write something between the positive and negative, what should I write? Can someone answer this? V. Let me do it this way. It's a nice symbol. I think I should stick to Apple. I don't know how to draw anything else. So what should I put between positive and negative? Apple. Why? Again, why? I know it's trivial. Better than that.
Because ground is 0.
Ground is 0. Perfect. Is ground is 0? Okay. So if ground is 0, how do you define any voltage between the positive and negative terminal? The positive terminal minus the negative terminal. So the positive terminal connected to Apple, and the negative terminal is connected to ground. So the voltage across that is Apple, right? I want you to just imagine. Now, the current IS, is it entering from the positive terminal of the combination of the resistors, or is entering from the negative terminal? Look at the current. It's going to the red highlight, right? So is that the positive terminal or negative terminal? Positive. When the current enters to positive terminal, is Ohm's law with a positive sign or negative sign? Positive sign. So that's why there is no negative sign, right? If the IS was backwards, then it would enter from the black highlighted part. That would make that would add a negative sign to the equation. Clear enough? Now, I want you to tell me what is I1 and what is I2. Who was next? Yeah. What is I1? No.
One is V over R.
V over? Use the red box. Do you remember the red box? I mean, I had probably 100 red boxes so far, but the red box. Yeah. Over? R1. So whatever that is, I'm going to divide it by R1. Do you agree with that? I have the expression for V. So IS R1, R2, R1 plus R2 divided by R1. And it's equal to IS divided R2, R1 plus R2. Okay? You can do the same for I2. These are highlighted in these two red boxes. And I want to take a moment, look at them, and see if they follow a good logic of circuit concepts. So for example, is I1 directly proportional to R1?
Inversely.
Inversely, actually. Technically is directly proportional to the other resistor. Is it logical? If it is, give me a very good textbook statement so I can write it here. Why the hell current is directly proportional to the other resistor?
Because the more resistance another resistor has, the more the current wants to go to the path of least resistance.
Yeah. Do you see the logic? Okay, if you have two resistors, one small, one big, the current passing through the small resistor is going to be bigger. That's why it's proportional to the other resistor. Okay. In fact, instead of these two equations, I have another set of equations that is equivalent to them. I'm going to write them here, but I prefer these ones. These are much easier. This is the equation for current division, and I'm going to write it. I1 is equal to IS multiplied by 1 over R1 divided by 1 over R1 plus 1 over R2. And I2 is equal to IS multiplied by 1 over R2 divided by 1 over R1 plus 1 over R2. You get why I prefer the red ones. They are much easier to handle. Okay? Compared with those two. But they are completely equivalent. In fact, if you just do the common denominator and do a little bit of math, you will get to this. So remember, if you are working, this is very important. If you are working with the inverse of resistors, use those ones. If you're working with the resistors, use the red ones. There is one case, or let me put it this way. Although I prefer the red ones, they have some limitations. What is that? They only work for two resistors. If it is more than two, you have to stick to that rule. Okay? Because this is only for two resistors. Since most of the time it is actually two resistors, these are more common, the red ones, but if it is more than two, you better use those ones. So let me put these in box as well, so you remember to memorize them as well. Okay. Let's find I5 here. Who was next? Let's just go random to Will. No, I want you to use current division.
Oh.
Yes. Yes, KCL would be the first idea.
Because it's more than two resistors, it would be the equations in the blue boxes.
Yeah.
So for I5, 1 over,
Okay, this is just to help you memorize. Always for voltage and current division, first write the value that is supposed to be divided. So what is that? The 5 amps is going to be divided. Now, what is that? After that, there's a fraction. So first draw the line, okay? What should be at the denominator? Are you working with voltage division or current division? Current division. So inverse of resistors, right? What should I write? What should be in the numerator? 1 over 5. It's 2.35 amps. This is something based on my experience. Usually students who become comfortable with the material after a while go for the red ones. And in the start of the process of learning current division and voltage division, the students usually always stick to the one in the other box because that's probably more straightforward. It might be more difficult, but I'm guessing your calculator is doing that, not you. So, and what is I8? Again, negative. Why? Because if you look at the direction that 5 amps is pushing into the combination of the resistors, but I8 is the opposite of that. So, negative, then 5 amps, 1 over 8 divided by 1 over 5 plus 1 over 10 plus 1 over 8. And it's equal to negative 1.47 amps. Question?
The reason I8 is negative is because it's pushing through the negative current, right?
The reason what?
The reason I8 is negative is because it's pushing through the negative current based on the diagram through the previous one. Where it is like the plus and the minus.
I'm trying to tell you something that you don't confuse with other conventions. Okay, see, do you agree that the combination of these three, the 5 amps is going into the top terminal of the combination, okay? But let's go inside the combination. That 5 amps is going to be divided between 3 paths. Some of it go down, some of it go down to the left, middle, and right. So the one that goes to the left, goes down to the left, is exactly in the same direction of the main current coming to that combination, right? That's why it is positive, because it agrees with 5 amps. But the 8 ohm, if you look at it, it's going up. While the main current is going down. It's like asking like this. I have a big pipe here, okay? And then after an intersection, it's divided into 3 pipes. Now the pipe is pushing some amount of water into the intersection. How much water from the third small pipe is going back? There's nothing going back. If you want to give a number, it should be negative because the big pipe is pushing current into the intersection. So all the small pipes are going to get some current and going down. Am I making sense here? Okay? So that's why the big pipe is the 5 amps, pushing current into the 3 combination resistors. Now, all of them should have some currents coming down because of the push of the source. Because I8 is in the opposite direction of the current that's being pushed down, that's why it becomes negative. Any more question? No? Minilab, ICA.